So now let's solve some cool examples on definite integrals. So the first example is evaluate integral of the limits 1 to 3 of 2x plus 3 or dx, right? Remember this is in the, let me pick a pen here. Remember this is in the brackets or dx. So in this case, I'll use this example to illustrate something small for you to understand things clear here. So this example, we could have done, should have go on and then compute everything and give it to you, but I want you to get some vivid understanding here. We can solve this by computing the area under the curve. So what is the curve here? So what you can do is that this is my function here, 2x plus 3. So we assume that our y equal to 2x plus 3. At the y-axis, x equal to 0, therefore my y equal to 3 at the x-axis, right? And then at the y-axis, at my x-axis, my y equal to 0, therefore my x equal to negative what? Let's say negative 3 over 2. Negative 3 over 2, right? That's what I will say it's my y and my x for now. And therefore, what I will do is, I don't want negative to come in. So what I can do is now, let me evaluate the function values from there. So let's say that for x equal to 1, right? Because we are using the limit of 1 and 3. X equal to 1, y equal to what? Let's see, let me delete this one first. S equal to 1, y is equal to, because we didn't give a limit to start from 0. We gave it to start from 1 to 3. So y equal to 2 times 1 plus 3. We are going to get what? 2 times 1 plus 3 is 5. And then y equal to 2, x equal to 2, 2 times 2 plus 3, 2 to 4 plus 3. Then we are going to get what? 7. And then at x equal to 3, we are going to get y equal to 2 times 3 plus 3, which is equal to what? 9. And therefore, that's my function value. So if I'm drawing a Cartesian plane like this, I'm going to get something like, so if I'm starting from 1, 2, 3, yeah, 1, 2, 3, and therefore at x equal to 1, let's say 1, 2, 3, 4, 5, right? And then let's assume that here is what? 9. So in assuming this, we can do something like at x equal to 1, the here is 5, so it started from 5. Okay, let me label this one different way so that I can. So let's put them there like we have, let's see, 1, let's see, we have 5, and then we have 7, and then we have 9. Let's do it that way. Yeah. So I'm assuming that this is the labeling for the y. So now at x equal to 1, I'm going to get 5. So at this point, 5 is here. At x equal to 2, I'm going to get 7. So 7 is here, right? And then at the x equal to 3, I'm going to get 9, and then 9 is here. So at the end, when I'm joining them, I'll join them like this. And then the interval will be up to this point. Now this is the area that we are looking for, but remember that it's a combination of a rectangle and then the triangle, right? So area of this rectangle plus the area of this triangle, we are going to get what? We are going to get area of this rectangle plus area of this triangle, we are going to get the total area. So now area of this rectangle here is going to be 2 because 3 minus 1 multiplied by, and then the height is what? 5. So we are going to get 10. And then the area of the triangle, so when we put 1 inside here, we are going to get 5. When we put 3 inside here, we are going to get 9. So 9 minus 5, we are going to get 4. So now we have here from here to here to be what? 4. And then here is the same 2. Therefore 4 times 2 times the half. Right, 4 times 2 times the half, we are going to get what? 4. So 4 plus 10 will give us what? 14. So this is what we are going, that means A1 plus A2. So if here is A1, here will be A2. So let's use our definite integral to do something here. So these are the integral from 1 to 3 of what? 2x plus 3 all dx. Therefore, integral of this, we are going to get what? 2x squared over 2 plus 3x, right? And then remember that after you are done with your integral, you bring the limit to be 1 and 3. And then you start your evaluation, because this one cancel this. So it's going to be x squared plus 3x and then 1 to 3. So doing the evaluation, you're going to get 3 squared plus 3 times 3. This is 1 minus 1 squared plus 3 times 1. And 3, 9 plus 9. It's what? 18 minus 1 plus 3. So here is 18 minus 1 plus 3 is 4, and then we are going to get 14. So as we can see, this one gives me the exact values, this also gives me exact values. Assuming that I'm using Riemann summation, I'm not using the area under the curve. I'm using Riemann summation. I need to divide it in a particular subinterval. And if I divide it into a particular subinterval, for example, I can get the change in x to be maybe 3 minus 1 over, if I want to divide it by maybe 6 subinterval, I'm going to, or maybe, let me say 6 subinterval, I'm going to get equal to 2 over 6, which is equal to 1 over 3. That's my change in x. And that change in x that I have over here, when I do this f of xi change in x, so let's use maybe we divided by 6, right? So 6, and this is our change in x. So that means when we start from 1, change in x is 1 plus 1 over 3 plus 1 over 3 as time goes on. But let me find something yes, simple change in x so that we demonstrate it here. So let's assume that we are picking 2 intervals. So interval is 2. So if the interval is 2, then it means that my change in x is going to be 2 over 2, which is what? 1. And therefore from here, I'm from 1, so I'm starting from 1, then plus 1, and then plus 1. That's how it's going to be. So basically the change in x is 1. Therefore, if I put 1 into the function, I'm going to get 2 times 1 plus 3, and I'm going to get the function value to be 5. And then if I put 2 inside, 2 times 2 plus 3, it's what? The function value is 7. And then 2 times 3 plus 3, and then the function value 3 plus 3, function value is 9. So since I have those ones over here, so it's going to be, the approximation is going to be 5 times 1 plus 7 times what? 1 plus 9 times 1. And as you can see, 9 to be 5 plus 7 plus 9. So when you put this one here, 10 to 16, 16 plus 5, that means it give us 21. So we can see there's a huge difference between 21 and that of what? 14, right? Then the error will be very huge error. So this is because I use only 2 rectangles to approximate this one. Only 2 rectangles to approximate. So this shows that the exact value is 14, but using 2 rectangles, the answer that I got is 21. And you can see how I'm getting some huge error. That's it. So the definite integrals help us to get the exact value of the area that we are looking for. So that's the first question. So the second question, they are asking us to that's the first one. I was just using it to explain certain things for you to understand. So let's look at the second question. For the second question, they are asking us to integral of 1 to 4 of theta plus 2 over square root of theta, or the theta. That's our second question. So this is the same procedure. You can pause the video and solve it, and then come and check your answer as well. So from here, what you need to do is that you simplify it first. You know that square root of theta is equal to theta power 1 over 2. So therefore, you simplify it in that way. You're going to get 1 to 4, and then you're going to get theta over theta power 1 over 2, right, plus 2 over theta power 1 over 2. Yeah, and all the theta. Don't forget that. And therefore, for expansion, you're going to get 1 4 theta, because when I bring this one up here, it's going to be 1 minus 1 over 2, right? And I bring this one up here, so we're going to get theta on 1 over 2 based on your indices, plus 2 theta power negative 1 over 2. That's how it's going to be, all the theta, and at the end of the day, you are going to get 1 4, and then this one is theta power 1 over 2 plus 2 theta power negative 1 over 2 the theta. So when you have this over here, then you start doing the integration, and when you do your integration, you are going to get equal to theta power 3 over 2, the normal integration that we have done already, over 3 over 2 plus 2 theta 1 over 2 all over 1 over 2. Remember that we add 1 to the top, and we do the same here. So it's going to be theta power 1 over 2 plus 1 all over 1 over 2 plus 1. That's why we got 3 over 2 and so forth. Yeah. So that's it. Let me continue from here. So now, since we have this, you can further, remember that we have 1 4, and then you can further bring it down to maybe 2 over 3, right? 2 over 3 square root of theta power 3 plus 4 theta. And this, I did this because this 1 4, because theta 1 over 2 equal to square root of theta. That's what I replaced. That's all. I didn't do anything again. And this one, I hope you know what it means from here. That's all. So basically this one now, you will start evaluating it. So when you evaluate it, you are going to get 2 over 3 square root of 4 power 3 because the upper limits plus 4 square root of what? 4. So these are upper limits, and then minus the lower limit, which is what? 2 over 3 square root of 1 all power 3 plus 4 square root of 1. And then at the end of the day, you are going to get 16 over 3 plus 8 minus 2 over 3 plus 4, right? And therefore, we are going to get 5 whole number 1 over 3 plus 8 minus 2 over 3 minus 4 equal to 8 whole number 2 over 3 or 26 over 3. So that's our answer. The next question that we have on our board is integral of 3 sine 2x. Integral of 3 sine 2x. So let's quickly look at that one. You can pause the video and solve this question before you come and check your answer. So 0 pi over 2 3 sine 2x dx. So now this is what we have. So based on that, just do your normal integration that you know that we learned earlier on. So integral of sine, right? You are going to get something negative. And first of all, I said that differentiate whatever in the box here and divide. Don't do it, right? So we are going to get 2 3 oh. So we're going to get 3. When we differentiate this one 2x, we're going to get 2. So times 1 over 2. When we differentiate sine, we are going to get minus cos. So minus cos 2x, right? So that's what we're going to. At the end of the day, this one is going to give us what? 3 minus 3 over 2 cos 2x. So now remember that we have a limit 0 to pi over 2. 0 to pi over 2. So what we need to do is that just substitute it. So negative 3 over 2, negative 3 over 2, and then cos 2 times pi over 2, and then minus, that's it. Now I'm done with the upper limit, minus negative 3 over 2 cos 0. Cos 0. So now with this, what we are going to get is negative 3 on 2, this is your normal algebra, on 3 and 2 minus cos 0 is 1. Therefore, negative 3 on 2 times 1. So when we have this, we are going to get 3 on 2 plus 3 on 2. And we are going to get 3. So that's our answer. And then let's look at the last example. The example is the last example is 4 exponent 2x. 4 exponent 2x. Let's quickly solve it as well. Question 4. 1 to 2 of 4 exponents 2x dx. So with this question, the same approach, you know how to integrate length. So when you integrate it, you just divide by the result of the differential of the exponents. So what you need to do is going to be, when I differentiate, I'm going to get 2. So I'm going to get 4 over 2 exponent 2x. And therefore we are going to get what? 2 exponent 2x. And remember that I have from 1 to 2, from 1 to 2, and then from there, what you can do next. You can do next is to do your evaluation, and therefore you are going to get 2 out, and then exponent 2 times 2 minus 2 out exponent 2 times 1. So now this is what we are going to get: 2 exponent 4 minus 2 exponent 2, right? 2 exponent 2. Therefore, you can factorize it 2 out, e power 4 minus e power 2. So that is that. So before I close this session, I would like you to try your hands on these various questions, and when you are able to finish that, please try and get in touch with me so that you can get the answers. So the first question is that the entropy, let me do trial. The entropy